Diagnose problems and issues with your car's AC system using an ʀᴇᴅ AC manifold gauge set. We'll also go over the different pressure readings you might get on the low side and the high side of your AC system and how you can use those readings to diagnose issues with your car. But not just that, we'll also talk about the electrical side of your AC system, like your AC pressure switches and your AC compressor clutch coil as well. And the AC system we're going to try to fix today is going to be on this 1987 Mercury Mountaineer. But you should be able to use the diagnostic procedures in this video to work on any car, year, make, and model. Alright, before anybody else says it, you guys like my hood prop? So a little background on this car before we get started. The owner tells me that the AC system on this vehicle stopped working about 2 to 3 years ago. But since it had only about 1 billion miles on it, they decided not to get it diagnosed or fixed. Alright, so I guess that wasn't much of a backstory. But anyway, let's get started. Alright, so on a car like this, first thing I want to do is to do a quick visual inspection. I'm going to take a look at the compressor, clutch, and pulley, make sure they're not physically damaged. Take a look at our AC lines, make sure they're in good physical shape, especially where they connect to the condenser. Of course, take a very close look and inspect the condenser as well. Alright, so all of that checks out on this car. So next I'm going to see whether there's any refrigerant on our AC system at all. Gonna do it like a redneck. Whoa! Yeah, it's got refrigerant. Alright, so that was surprising. I didn't expect this thing to have any refrigerant actually. But anyway, next, we have no choice but to whip out and play with our toy. And by that I mean our AC manifold gauge set. And by the way, if you're interested in this tool or any other tools or products I end up using in this video and you want to buy them online, I'll put links to where you can buy them for cheap down below in the description box, so don't be afraid to click on them and check them out. Now for those of you that are not familiar with these, let me explain to you how they work. So on an AC manifold gauge set, you'll have 2 sets of gauges. You'll have a red one for your high pressure side, and the numbers you want to use are going to be these PSI numbers inside this small circle here. And then you have a blue one for the low pressure side, and again you want to use the PSI numbers inside here. And then you have these quick connect couplers that will attach to the service ports on your AC system. And you got the red one again for the high pressure side and the blue one for the low pressure side. Now for reading pressures inside your AC system, these are all you need to pay attention to. But you have also these valves that open up your high pressure side and low pressure side to this yellow line. Now when you open these, you only open them when you're about to evacuate the system or vacuum the system or add refrigerant, all through this yellow line. So under normal circumstances, both these valves, well, there's one blue valve here, there's supposed to be a red one here, but again, this is an ʀᴇᴅ manifold, but it still works. But anyway, these 2 valves need to be closed so that refrigerant doesn't go from your AC system into this yellow line when you're only checking for pressure. Alright, so next we'll grab one of our quick connect couplers and make sure that this valve inside here is out all the way by turning this counterclockwise. Alright, so next you'll grab your quick connect coupler, pull back on this, install it on your service port, push down, let go, make sure it's firmly attached, and that's it. And you can't really connect these to the wrong one because the high pressure service port has a larger diameter than the low pressure side, so these are pretty dummy proof. So next, after you install them, you want to start running down your valve. And as soon as our Schrader valve opens, and if we have any refrigerant in the system, we should get a reading. As you can see, we got about an 80 psi or so of pressure on our high pressure side. Alright, so next we'll do the same thing on our low pressure side. And you should have more or less the same pressure on the low pressure side with your engine off and AC compressor clutch not engaged, obviously. As you can see, we got about the exact amount of pressure on both sides. We got 80 psi here and 80 psi here as well. And that's called your static pressure, and that's exactly what you want to see. You want to see the same pressure on both sides when the compressor is not working. Now as far as why that is, well, let's go over quickly of how an AC system works on your car. We will start at your AC compressor. Alright, so normally when you do not have your AC on, your AC compressor, or rather the pulley here, is basically just freewheeling and turning with your drive shaft. But when you turn on your AC, and if you have enough refrigerant in the system, your car's HVAC module will engage your AC compressor clutch. So right there in front of the pulley, that's your AC compressor clutch. And here's a connector for AC compressor clutch coil that when activated engages your AC compressor clutch. And when the clutch is engaged, your AC compressor starts working and it takes refrigerant from the low side, compresses it, and sends it to where your high side starts at your AC condenser. Then from your AC condenser, depending on your setup, refrigerant goes to either an orifice tube or an expansion valve. On this car here, we have an orifice tube, which basically both of their job is to force the compressed refrigerant through a very small opening or orifice. And when that happens, and as the refrigerant expands from there, it will go to a low pressure side and expands quickly and therefore cool down rapidly. And when that happens, it goes to your evaporator, which is usually in some godforsaken place inside your dash. And also that's where your blower fan is. Your blower fan blows the warm air over your evaporator. Your evaporator absorbs the heat from that air, therefore cooling it down, and that's how you get that nice cool air inside your cabin when you do have a working AC system. And from there, if your AC system has an orifice tube, the refrigerant goes to what's called an accumulator, which is this guy right here. Now the job of your accumulator is to filter the refrigerant and make sure there is no debris or any moisture in the refrigerant, but more importantly is to capture any refrigerant that's in the liquid form so it doesn't pass on from here into your compressor, because if that happens, the liquid refrigerant can damage your AC compressor. So when the AC compressor is working, you're going to have a lot of pressure on your high pressure side, which is in red here, and when it passes your orifice tube or expansion valve, it goes to the low pressure side, which is in blue here. And the reason why you want to see equal numbers when the compressor is not engaged is obviously when the compressor is not engaged, refrigerant starts leaking back from the high pressure side into the low pressure side and being equal on both sides. And that's if you have a working AC system, or let's say if you have a clogged orifice tube, it's not going to allow for the refrigerant to pass from the high pressure side into the low pressure side, and therefore you're going to have different numbers for each side. Alright, so next we're going to get in our car, start our engine, and turn on our AC and see whether our AC compressor clutch engages or not. Now since we have enough pressure in our low side, our AC compressor clutch should engage if the electrical circuit is working properly. And if you're wondering, pretty much anything past 25 or 30 psi on the low side should allow for your AC compressor clutch to engage. I'll explain why that is in a little while, but for now, let's turn on our AC. So we'll put this on max. Make sure this is in the cold position. Alright, that feels a little funny. Make sure this is on max as well. So here you guys can actually see the clutch engage and disengage on this AC compressor. Alright, so here's our pressure readings. Now when the compressor clutch engages, like right now, you can see the needle on this side goes to about 140, 135. And you want to take your readings when the AC compressor clutch engages, by the way. And then here engaged again, and on the low pressure side it's at about 30, and maybe 32 or 3. And on the low pressure side you can see that right there, you heard it, the clutch engages right when this hits 35 psi, and as it goes down it disengages when it goes below 30 psi. Alright, now that we have these numbers, what do they mean and how can we use them to diagnose issues with our AC system? Now, these numbers are going to be a little different from car to car. You know, every system has its own numbers for different temperatures and humidity when you do the test. But from experience, I can tell you that these numbers are actually okay. They pretty much indicate that we might be slightly low on refrigerant, and that's why the compressor clutch keeps engaging and disengaging. Alright, so the way your AC compressor knows when to turn on and turn off is through your low side AC pressure switch or compressor cycling switch, which again is on the low side. This 2-wire switch that you see here on our accumulator. So basically this switch is usually in the open position. In other words, when it's open, it doesn't let current to pass through it. But when you have enough pressure inside your low pressure side, it pushes up against the switch and it closes the connection inside this switch and allows for current to pass through. And when current passes through that, it goes from there usually to your AC compressor clutch, which is already grounded. And when it gets that current from your AC low pressure side switch, it turns on and starts pumping the refrigerant from the low side into the high pressure side. But then again, as it pumps the refrigerant from the low side to the high pressure side, the pressure inside your low side goes down below a certain threshold, and when it goes down below a certain threshold, your low pressure side switch opens, and when it opens it cuts the current to your compressor, and that's when it disengages. And then the whole cycle repeats itself, and then when you have low refrigerant, this just happens more and more quickly. Now, for whatever reason you don't have access to the repair manual for your car, you can use these numbers you see here to give you a general guide. So, for example, right now over here is about 75 degrees Fahrenheit, above 60% humidity. So on the low side, we should have 27 to 42 psi of pressure. And on the high side, we should have 128 to 181 psi of pressure. And I know that's a bit of a wide range, but you can see we have about 30 or maybe 31 or 32 on the low side, and then we have 140. And for both sides, we're on the lower side. So we can conclude that we are just a little low on refrigerant in this car's AC system. All right, so now let's talk about if you get different numbers than the ones we got here. So now let's say we have the same number or the same pressure on both sides, even when the AC compressor clutch is engaged. If that's the case, let's say you're getting 80 psi on both sides with the compressor clutch engaged and the engine running, basically means you have a short AC compressor. It's basically not compressing the refrigerant that's coming to it from the low side, or perhaps maybe there are check valves here that keep refrigerant from this side going out and not back in, and from this side coming in and not back out. Whatever the case may be, you have a bad AC compressor and you need to replace it or rebuild it. Alright, so next let's say you have higher pressure on the high side than what you're supposed to have, and then lower than what you're supposed to have pressure on the low side. Now if that's the case, and if it's bad enough, your AC compressor clutch may not even engage because the pressure on the low side is going to be so low where the low side pressure switch is not going to close and allow current to flow to your AC compressor clutch. But basically it means that you're going to have a clog in your high pressure side, and the main culprit on a setup like this is going to be your orifice tube. Okay, so another scenario would be when you have lower than expected pressure on the high side and then higher than expected pressure on the low side. Now this is going to be more common with setups that have an expansion valve instead of an orifice tube, but basically it would mean that the expansion valve is stuck in the open position, and this compressed refrigerant on this side can easily get into the low pressure side, raising the pressure on that side and lowering the pressure on the high pressure side. It also could mean that you could potentially have a check valve inside your AC compressor on the low side that's stuck closed and doesn't let the refrigerant to get inside the compressor easily. But generally speaking, you get these numbers when you have an expansion valve and it's stuck open. Alright, so there's that, but as far as what's wrong with this car besides the low refrigerant, well, you're probably not going to believe it. The problem is this guy right here. See, this is completely shot and it's not working. And I believe that this is actually broken all the way in the hot position. Because with the engine running and the AC off, and even though that this knob, I'm going to put it here on the cool side, the air coming out of these air vents is super hot. So that's why I don't feel the cool air coming out of this, even though that their AC system is kind of working. It's a little low on refrigerant, but it should still cool the air coming out of these air vents. So in other words, for the last 3 years in the Southern California heat, their AC system works fine. It's just that knob that hasn't been working right. Hold it. I spoke way too soon. So this thing being a 97 mercury, I imagine this controlled for the temperature would be either mechanically controlled by cable or by vacuum, but as you can see, this is actually controlled by a potentiometer here. So basically the way this works is that when you turn the key on, there's current available at the potentiometer or your temperature control knob. As you turn that temperature control either to the right or to the left, the resistance in that potentiometer changes, and as a result the current flowing through it and out of it changes as well. And that changing current from there goes to your blend door actuator on your heater core assembly, and it either opens or closes that blend door, which as a result allows for either air from your heater core or from your evaporator to flow through your vent system and then out of your air vents. Alright, so next with key on, engine off, I'm going to use my test light to see whether we have current at any of these pins here, and as you can see we do have current on this wire all the way to the right. Next you want to go and attach your test light to the positive side of your battery and then check for a ground at this connector. As you can see, on the one all the way to the left, we have ground. Alright, so basically current comes through the wire on the right, through this potentiometer, and as you turn the knob, the resistance inside there changes, and the signal voltage or current goes through the center wire back to our blend door actuator. So here I've attached my test leads to those two wires on the right and the middle, and as you can see, we got about 5,000 ohms of resistance right now. So if this potentiometer is working correctly, as I turn this knob for our temperature control, the resistance we see here should change. And as you can see, indeed it does. So this potentiometer is not our problem. So down the rabbit hole we go. Next, up to our blend door actuator, this guy right here. This thing sits on top of this plenum like this, and this piece here opens and closes the blend door in there, which allows for either hot air or cool air or cold air to flow through our vent system. So again, if this is working correctly, as we turn the temperature knob, this thing should move as well. And as you can see, it does move as we turn that temperature knob. Alright, so unfortunately it seems that the problem is the actual blend door, as in the mechanical blend door inside of that plenum itself. And from the research I can find online, it seems to be a common problem where it breaks and then the hot air and the cold air combine and come out of your air vents together. And unfortunately the cure for that is that you have to replace that entire housing with the blend door inside of it. You can't just replace the blend door. And in order to replace that housing, you have to remove it from the inside of your dash, and I'm sure it's a pretty big job. I haven't even looked at the labor hours for that, but I have to talk to the owner and see whether he wants to do that or not. I have a good feeling that he's not going to bother with it. Alright, I know everybody was waiting for a more fulfilling outcome, but you know, as that one philosopher once said, you can't always get what you want, but if you try sometimes, you can make lemonade with it. Or something like that. But anyway, hope you enjoyed this video. If you did, do me a favor and share this video on your favorite social network. And also click on these other related videos, of which I put links to on this side of the screen. There will also be links down below in the description box as well. Alright, thanks for watching. I'll see you guys next time.